गाडगे सर आलेत काय सगळे?
हॅलो,
हा
चालू करूया.
हा 10:30ला शाम चालू करायची. प्राचार्य साहेब येणार आहेत ते?
हा, आले, जॉईन झाले.
बर.
Recording in progress.
गाडगे सर स्टार्ट करूया.
हां करूया.
ओके.
चालू करूया काय?
हां करूया.
करा.
Okay, good morning to all of you. Department of Statistics in collaboration with IQAC organizes a national online conference on statistics and its applications 2023, that is NCSA 2023, with the Department of Statistics and IQAC of Dr. Ganpatrao Deshmukh Mahavidyalay Sangola, formerly known as Vignan Mahavidyalay Sangola, Taluka Sangola, District Solapur, Maharashtra, India, welcomes you for one-day national online conference on statistics and its applications 2023. The head Department of Statistics and convener is Mr. V.K. Ghadge, the organizing secretary and anchor Dr. J.V. Thombre, the IQAC coordinator Dr. S.S. Dasade, the members of organizing committee, the organizer and principal of our college Dr. S.M. Mulani have taken efforts to make this online conference successful along with entire teaching and non-teaching staff of college. Statistics plays a key role in the development of modern science, management and many other important applied areas. With this motivation in mind, the department was established in 1991. The department is running BSc first and BSc second courses. Apart from teaching, the department has actively participated in research activity and overall development of students. For better exposure of research, Department of Statistics in collaboration with IQAC has organized a one-day national online conference on statistics and its applications, that is NCSA 2023. We are starting with inaugural session and keynote speaker is Professor V.B. Gute, Director, School of Computational Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur, and President of inaugural session is Dr. S.M. Mulani sir, Principal of our college. I request convener and head Department of Statistics, Mr. V.K. Ghadge sir, for welcome address. Mr. V.K. Ghadge sir, it's over to you.
Good morning to one and all. At the outset, I welcome you all for the inauguration of online national conference on statistics and its application organized by Department of Statistics, Dr. Ganpatrao Deshmukh Mahavidyalay Sangola. The institution Sangola Taluka Shetkari Shikshan Prasarak Mandal Sangola was established on 15th May 1969 with the aim of giving availability and facility of education to socially backward societies, to Bahujan society including Harijan, Girijan, farmers and laborers, and socially deprived from progress in the region of Sangola Taluka. Since its establishment, the institution has started high school, junior college, professional courses of +2 sections and Dr. Ganpatrao Deshmukh Mahavidyalay. Dr. Ganpatrao Deshmukh Mahavidyalay was established on 23rd September 1991. Our president, late Dr. Ganpatrao Deshmukh, has eminent personality. He bears a world record of being MLA for 55 years, belongs to one party, that is Peasant and Workers' Party of India, and one constituency. He was active not only in the politics but also in the social works. I am very fortunate to have Professor Dr. V.B. Gute sir, Director, School of Computational Science, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur, as a chief guest for this inauguration function. And we feel blessed, Principal Dr. S.M. Mulani as a president for this program. I welcome both these eminent personalities for this function. I also welcome resource persons for today's online national conference, Professor Tirupati Rao Padi, Dr. Deepak Sakte and Dr. Anjali Upadhyay. I also welcome Principal Dr. B.G. Kore, Professor Dr. K.G. Poddar and Dr. Naveen Chandra, Dr. Nilesh Jadhav and Dr. Santosh Sutar. as a chair session. I welcome IQAC coordinator Dr. S.S. Dasade as well as all teaching and non-teaching staff of Dr. Ganpatrao Deshmukh Mahavidyalaya Sangola. I am happy to share with you that conference has got good responses with 77 participants along with 25 paper presentation. I welcome all these participants from every corner of the country. Again, I welcome all of you. Thank you.
Thank you, sir. Now I request IQAC coordinator Dr. S.S. Dasade to introduce today's keynote speaker, Honorable Professor Phoebe Gute, sir. Dr. S.S. Dasade.
ओके, थँक्यू. सांगोला तालुका शेतकरी शिक्षण प्रसारक मंडळात डॉक्टर गणपतराव देशमुख महाविद्यालय सांगोला, डिपार्टमेंट ऑफ स्टॅटिस्टिक्स इन कोलॅबरेशन विथ IQAC organizes a national conference on statistics and its applications. The president of inaugural session, Honorable Principal of Dr. Ganpatrao Deshmukh Mahavidyalaya, Professor Dr. Yasham Mulani, Chief Guest of the conference, Dr. Vikas Gute, Coordinator of the conference, Professor V.K. Ghadge, one of our colleague, Co-Coordinator, Dr. J.V. Thomre, invitees and participants of the conference. My dear friends, ladies and gentlemen, I am immensely happy to welcome you to e-conference and Dr. Ganpatrao Deshmukh Mahavidyalaya to the National Conference on Statistics and its applications. First of all, let me record my gratitude to the President, Secretary and Director of Sangola Taluka Shetkari Shikshan Prasarak Mandal for organizing this type of conference, and my colleague have entrusted me and Professor V.K. Ghadge with the responsibility of organizing this conference. We organize national conference or events to encourage the students and researchers, especially from the rural areas. Approximately almost all of the presentations and invited talks to this conference are focused on applications of statistics. I believe that the young scientists from all over the country will benefit greatly. The conference has been prepared at digital platform, allowing for good discussions, and we hope this presentation has been satisfactory. Dear friends, we have done everything to make this digital platform better and easier for you. Now, I would like to conclude my speech by presenting the chief guest of this national conference, Professor Vikas Gute, sir. He did his MSc and PhD in statistics, and he is Professor of Statistics. He is Professor and Director, School of Computational Sciences. He is also Head of Department of Statistics and Mathematics, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. He is ex-Register and In Charge Pro Vice Chancellor, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. He is the Director, Knowledge Resource Center, University Library. Also, he is contact person for SET examination at Solapur Center. He did work on important committees of the university. He is the member of Budget Preparation Committee, Board of Examinations and Evaluation, Statute, PhD entrance test, PG entrance, Purchase Committee. He also did work in Library Committee, Scrutiny, AAA Committee, LIC, and also he did work on Selection Committee. He is a member of Senate, Management Council, Governing Body of Autonomous Colleges, Academic Council, Research and Recognition Committee in Statistics. He is a Chairman, Board of Statistics in Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. He is also member of Board of Studies in Statistics and Computational Applications, Savitribai Phule, Pune University, Pune. He worked as a member of Studies in Statistics in some 4 different universities from the Maharashtra. He is a member of Board of Studies in Business Economics, Banking Mathematics and Statistics from Solapur, Shivaji University, Kolhapur. He is a member of Board of Studies in Business Statistics and Business Mathematics of DG College of Commerce, Satara. He is also member of Board of College and University Development Committee and member of Board of Studies in Statistics of some 6 autonomous colleges in Maharashtra. He is a member of Ethical Committee at Pandit Deen Dayal Upadhyay Dental College, Solapur. Dr. Vikasji Ghute is honored by International and Academic Excellence Award 2022. He is also honored by Sarvapalli Radhakrishnan Best Teacher Award in 2021. He is also honored as a Best Teacher Award of Punyaslok Ahilyadevi Holkar, Solapur University, Solapur. He is honored by Devang Mehta National Education Award as a Best Professor in Department of Statistics. Professor Dr. Vikasji Ghute is also honored as a Maha Avatar 2018 CASI Community Leader, CASI Global Mumbai. Dr. Vikasji Ghute is associated with 4th Finance Commission of Maharashtra, 6th Economics Seniors National Statistical Systems Training Academy, Ministry of Statistics and Program Implementation, Government of India. He is also associated with RUSA, Pandit Madan Mohan Malviya National Mission on Teachers and Teaching of Government of India. He is also associated with Indian Institute of Science, Education and Research, that is ISER, Pune. He is a member of editorial board of Punyaslok Ahilyadevi Holkar University Research Journal. Dr. Vikasji Ghute has Google Scholar citations of 217. His H index is 7, where he is having I10 index of 5. He has published 45 research articles in well-reputed and impact factor journals. Dear friends, we are here with this great personality. With this, I invite Dr. Vikasji Ghute for his inaugural speech. Thank you so much. Over to Dr. Vikasji Ghute, sir. Thank you, sir.
Thank you, sir. Now I request our chief guest, Professor V.B. Ghute, sir, for keynote address. It's over to you, sir.
Thank you, sir. Thank you, Dr. Desade, sir, for my introduction. All the dignitaries joined for this inaugural function. President of this function, Principal Dr. S.M. Mulani, sir. Convener, Professor Vijay Kumar Ghadge, sir. Invited speakers of today's conference, Professor Tirupati Rao, Dr. Deepak Sakte, Dr. Anjali Upadhyay ma'am, then chairpersons for today's conference, my friend Principal Dr. Kore sir, Dr. Naveen Chandra sir, Dr. Poddar sir, all the participants, then researchers and student friends. Good morning to all and very warm welcome to this inaugural function of National Conference on Statistics and its Applications. It is my pleasure to deliver the opening remarks on National Conference on Statistics and its Applications organized by Dr. Ganpatrao Deshmukh Mahavidyalay, Sangola. At the outset, I would like to begin by expressing my sincere appreciation and gratitude to organizers, Principal Dr. Mulani sir, Professor Ghadge sir, entire organizing committee for organizing this important conference. It is a great pleasure to have 3 invited speakers with us in this conference to share their knowledge regarding statistics and its applications in various fields. The theme of conference is statistics and in its applications, and with the hope that the statisticians can take an active role in improving the society welfare. The aim of this conference is to provide a forum for researchers, academicians, students, and industries to exchange their ideas, to communicate and discuss research findings and new advancement in statistics. The conference will be a venue to communicate and discuss how statistics can give contribution to improving society welfare and to give solutions to problems faced by industries and other sectors. As we all know, statistics plays a very important role in our day-to-day life, to our daily expenses, to government policies. Everything is based on statistics. It also plays a role in business, industries, health science, and many other fields where statistics is used regularly. There are many uses of statistics in other fields also. In education, all the subjects directly or indirectly use statistics to understand the concept of their chapters. So in business or in markets, it will be help us to describe market conditions, inform advertising, set prices, track demands, and many more applications we can observe. It also helps to analyze past performance, predict future business performance, and lead organizations effectively. Statistics is also used in every aspect of life, such as in data science, robotics, business, sports, weather forecasting, and many more applications we can observe. The theme of today's conference is statistics and its applications. So I will now highlight some areas of statistics and its applications where we can focus in future. The first application of statistics is in data science. As we know, statistician is one of the top 10 fastest growing jobs in the world. Going by the rate at which world is generating and collecting data, it is not surprise that the expertise of those who can effectively analyze this data. It is of great demand and is one of the most important applications of statistics. Statisticians or experts help collect, study, and extract relative information from the vast and complex data. So this information is then applied to validate and further research, make some sound decisions, and derive public initiatives. In research also, statistics is very useful in all the disciplines. It is important part of most science as well as social science subject. It helps the researchers in the test of hypothesis and arrive some reliable conclusions. The data generated from experiments and studies is of course never straightforward. So one has to take into account the randomness as well as uncertainty and eliminate coincidences and arrive at most accurate finding. So statistical analysis helps to reduce or eliminate errors so that the researchers can confidently make conclusions that will then direct the further research. Then next application I would like to focus is when we use statistics in research, particularly in social science research, so it requires the review of literature. So meta-analysis of literature reviews use the statistics in best way. Before a researcher start new research, so it is necessary to perform comprehensive literature review of all available published information on a specific topic. However, it is always difficult to make one definite conclusion from the multiple studies, especially if studies follow different research methodologies, have been published in different journals, or spread over large time of range. A statistical analysis of this study helps extract the common truth underlying all these studies or uncover hidden patterns of relationships. One more important application of statistics is in clinical trial designs. So in clinical trial design, statistical analysis is in designing clinical trials. When a new drug or treatment is discovered, it has first to be treated on group of people to understand and its efficacy and safety. A clinical trial involves selecting a population, sample size, defining time range over which to monitor the treatment, designing the phases, and selecting parameters that will decide how effective the treatment is and if it is better than existing one. Biostatisticians can take on the task of performing statistical analysis of study, helping not only to design it but also analyze and determine the outcomes. In epidemiological studies also, statistical applications are there. In this study, to determine the link between cause and effect of disease, a statistical analysis involves identifying the most likely cause of disease. This information is used to develop public health policies and implementation of preventive healthcare programs by the nation or by the states. One more applications of statistics is statistical modeling. Statistical modeling involves building a predictive models based on pattern recognition and knowledge discovery. It is used in environmental and geographical studies, predicting election outcomes, survival analysis of populations, and many more applications can be done by using the statistical modeling. As we know, good governance also uses the applications of statistics. Good governance means making decisions that benefit the constitution in an efficient and effective way. Governing the nation, the data and statistical knowledge should play a major role in the process of making decisions and setting the policies. So it requires good data, and while collecting massive amount of data becomes easy, but the collecting a good data remains difficult. So this is where the statistician can help in a variety of ways. We can help organizations understand the difference between good and bad data, which is the crucial for good governance. So we can help to educate people ranging from politicians and policymakers to general public on appropriate use and interpretation of data. Finally, we can play a major role in improving statistical methods for more efficient and accurate data collection and analysis of data. So these are the some topics which are required for further research. So it can be the direct applications of statistics for society as well as government and non-government sectors. So I am hoping this conference will provide an important opportunity to exchange the newest practices in statistics and share knowledge of emerging methods and standards for solving the problems of society using statistical techniques. So I wish you a very successful and productive discussions during this conference. With these few words, I conclude my speech, and once again I thanks to organizers for giving me opportunity to be a part of this conference. Thank you very much.
Thank you, sir, for your remarks on applications of statistics in various fields such as data science, literature review, clinical trial designs, statistical models. So you have explained in very well. So thank you, sir. Now I request our principal and president of inaugural session, Honorable Dr. S.M. Mulani sir, for his presidential remark. Dr. S.M. Mulani sir.
Good morning, all of you. Respected Professor Dr. Phoebe Gute sir, Convener Mr. Vijay Kumar Ghadge, IQAC Coordinator Dr. S.S. Basade, all resource person and session chair, my colleagues and dear participants. It is a matter of great pride to be a part of statistics conference. As we all know, statistics has its wide applications in every aspect of life. There is no field which does not require statistics. Nowadays, various statistical techniques are being heavily used in other disciplines of science. As a result, new branches of science are emerging and flourishing to greater extent. Recently developed applicative branches of statistics are biostatistics, actuarial statistics, astrostatistics, and many others. It is said that data is the fuel of new world. Whoever has the data, he will be called to be a rich person. In the upcoming days, data driven techniques will be utilized in every sector because of a computer's data is being generated and stored in large volumes. We have useful informations from these data statisticians are working hard to develop new techniques. In the age of artificial intelligence and chat GPT, statistics has got tremendous importance. I am really happy that Ghadge sir has organized this national conference in statistics. In his talk, Professor Gute sir has also underlined the importance of statistics in different disciplines. I am thankful to him on behalf of our College for spending time with us. I wish all the very best for the conference, and I hope this conference will prove to be fruitful for your future research journey. I thank the organizers for giving me opportunity to interact with you. Thank you.
Thank you, sir, for your presidential remark. On behalf of organizing committee, I pay vote of thanks for this inaugural session. First of all, I am very much thankful to Professor V.B. Gute sir for accepting our invitation, and in spite of his busy schedule, he has presented a wonderful talk as a keynote address. So thank you, sir. My sincere thanks goes to Dr. S.M. Mulani sir for giving us a permission to organize NCSA 2023. I am thankful to IQAC coordinator Dr. S.S. Dasade and head Department of Statistics Mr. V.K. Ghadge for giving me a responsibility as a organizing secretary. Thank you all of you for being with us. I declare with permission of organizer the inaugural function is over.
ते चालतच असतं सर, रात्रभर चालू आहे तिचे.
Now we will start invited sessions. The invited sessions comprising of 3 invited talks. First invited talk will be delivered by Professor Tirupati Rao Padi. Second invited talk will be delivered by Dr. Deepak Sakte, and third invited talk will be delivered by Dr. Anjali Upadhyay. So we will start with invited talk first. The topic of invited talk is Hidden Markov Model of Financial Marketing, and the speaker is Professor Tirupati Rao Padi. He is Dean, Faculty of Mathematical Sciences, Pondicherry University, Pondicherry, and the chairperson is Professor V.B. Gute sir, Director, School of Computational Sciences, Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. I will hand over the session towards Professor V.B. Gute sir. Sir, it's over to you.
Yes, thank you, sir. Now, first, I will introduce Professor Tirupati Rao. Dr. Tirupati Rao, currently working as a Professor of Statistics and Dean, Faculty of Mathematical Sciences, Pondicherry University from January 2012. He initially joined there as Associate Professor. He is also worked as Associate Professor and Professor of Statistics at SV University Tirupati from July 2007 to December 2011. His teaching career was started in November 1988 and at Mrs. AVN College, Visakhapatnam, a state government aided college, and worked with different capacities like ad hoc lecturer, UGC regular lecturer, reader, and head of departments up to 7th July 2007 for a span of around 19 years. He has served Pondicherry University as HOD of Statistics, Nodal Officer of AISHE, Nodal Officer of Swachh Bharat, Member of Academic Council, Member of University Court, etc. He also served the Government of India with capacities of Member, Bureau of Indian Standards, Government of India, Member Advisory Committee, Economics and Statistics, Government of Pondicherry, etc. His research area is stochastic modeling, optimization methods, and statistical computing. Now today's topic is hidden Markov models for financial marketing. Now I request Professor Tirupati Rao to deliver his lecture.
Thank you, sir. Thank you very much, Professor Vivek Gute sir, for your nice and a cordial introduction to the audience. I'm really delighted to participate in this program, being a very vibrant academic activity that is organized by Ganapatrao Deshmukh Mahavidyalaya Sangola.
Sir,
So
join
I
झालेत
have
का?
to- Am I audible, sir? Hello?
Yes, sir, it's audible. Yes.
Yeah.
Yes, sir, you are audible.
Hope I am visible also. Right. So now it's my turn to speak, and on the I had to share my screen. Is it so? Just a moment, sir. I have to make.
गुटे सरांचा तिथला माईक कुठला तर चालू आहे त्यांचा इथं मला सापडून आपण कुठं त्यांना सांगा.
Hope my screen is visible.
Yes, sir.
Yes, sir, it's visible.
So in fact, I have given my consent to give a talk on hidden Markov models of the financial marketing. However, when I am preparing this presentation, I am in the impression that I had to give some basic points with the Markov models. Then only it will be rational for me. So therefore, I am just confined to the top of my talk is two-state Markov models of financial marketing studies. You are all aware that, as just now Professor Bhutesab has mentioned, that statistics is now indispensable discipline, and it is catering its services in almost all disciplines. As a part of that, there is one interesting works of statistics, or one interesting parts of the statistics is called modeling. So stochastic modeling is one of the areas where we have to make use of for prediction purpose or estimation purpose. In this talk, I am going to speak on the aspects like what is Markov model, what is the two-state Markov model, and finally, I would like to explain how to derive different probability distributions involved with this two-state Markov models through transition probability matrix. So construction of transition probability matrix, everything will be discussed. My total talk will be in two parts. Part one is theory and classical development. Part two is a real-time data from stock market that is applied to this one, and finally results are explored and interpretations are arrived. With this, my talk will be completed by saying that my findings. Markov chain modeling for stock market prediction. What it says that prediction of the stock price behavior has become a high and interesting research area. It's critical necessity for every profitable company as well as for investors and shareholders in making a confident selection of solid investment in the stock market. To analyze and forecast the movements of stocks A variety of statistical projections methodologies have been used. The methods like artificial neural network 2013, data mining and regression in 2011, ARIMA modeling 2014, head and shoulder methods, etc. are the considerable things that we have made use of it. So many of the above forecasting models require stationary time series data. There are two types of time series data. One is transient and another is stationary. So any data initially it is considered to be transient. We have to explore the stationarity among the transient data to arrive to the patterns within the data. So arriving to the patterns of the data is nothing but exploring the hidden probability distributions behind the data sets. So in practice, financial time series data are frequently non-stationary and non-linear in nature. They cannot be considered as additive models simply, necessitating the use of non-stationary time series models. Now, this is some reported work which was there in the studies. So I don't want to make a repeat of these things. Anyway, the study what we have to consider here is that I want to give some insights of this study. MCM has Markov chain modeling has been applied by many researchers in different times. Of course, the first man, a Russian mathematician Andrei Markov. Applications in finance is mostly started in 1999. Stock valuation from 1994 to 2017, we have different kinds of models. Credit rating modelings, etc. are the models what we have. It's not changing, Oh yeah, now it is changed. The reported literature reveals that Markov chain models have been found as an accurate and efficient methods to analyze and predict the stock prices movements in the stock market. In this study, we have developed the probability distributions for the two-state Markov chain models along with their descriptive statistical measures. Of course, math formula derived later, numerical values also explored. We have applied two-state Markov chain on the closing prices of Nifty Bank. Now, to obtain two-state Markov chain, the objectives are to obtain two-state Markov chains, to obtain the probability distribution of each state in a sequence of length 1, 2, and 3. Of course, 4 also mentioned, but I have not given any information on the 4 state. To derive the explicit functional relations of statistical measures, that means deriving mathematical relations for this, for proposed probability distribution, generating functions of the proposed probability distribution, but finally applying the two-state Markov chains for real-time data, that is stock market data, for analysis and prediction of the short-term and long-run behavior of the share prices. And also it is determining the expected number of visits to certain state. Finally, computing the expected first return times of various states. These are the things we are going to discuss. Of course, if you observe the stock prices fluctuations increasing and decreasing, there are 2 states now I considered for our study purpose. These 2 states are obtained on the basis of difference between current day value to the previous day value. That means previous day value will be subtracted from the current day value so that you will know that whether there is an increase in price or decrease in price. If the difference between the current day and the previous day is greater than 0, then it is denoted as increment state. Whereas the difference is less than or equal to 0, we consider it as decrement state. This is the schematic diagram for understanding the two-state model. In a study of N1 plus N2 items, in which N1 times increment is observed, N2 times decrement is observed, then initial probability will be pi1 become N1 by N1 plus N2, pi2 become N2 by N1 plus N2. This A11 is the transition probability from the previous trial with result state I and the current trial's result state is I. What it means that the previous day it is in increment state, the current day is also in increment state, that transition probability will be denoted as A11. Similarly, A12 means current day is decrement given that the previous day is increment. Next, A21 means current day is increment given that the previous day is decrement. And A22 is the probability that the current day's result state is decrement given that the previous day's state also decrement. This is way you have to understand these transition probabilities. Right. In fact, these transition probabilities are the parameters. These are the parameters to be estimated from the given data. From the given data, we need a probability distribution. So our work is going to explain how to construct a probability distribution out of this transition probability matrix. Further, how to explore different statistical measures by deriving math formula, and further application part come into the course. Now, nodes represent the states, edges have weights representing Aij. I is taking 1 and 2 states, and J is also taking 1 and 2 states. Phi I is initial probability for the ith state, phi I greater than or equal to 0, and sum over I equal to 1 to 2, pi equal to 1. And further, Aij transition probability from ith state to jth state is, it is defined probability that xn plus 1 equal to means the current trial result state is j, given that the previous trial the result state is I. In otherwise, you can say that it is future trials result is state j, given that the current trials state is I. So this is the basic structure of transition probability matrix. Of course, row sums of transition probability matrix equal to 1. The rules for transition probability matrix is that matrix elements are probabilities, row totals are 1, and mostly it is square matrix. And if you say that assume that there is a 1 day sequence, if you want to go for it, the probability distribution of the states I and D of 2-state MCM in single day sequence are derived in this section. Moreover, for every derived probability distribution, the formula for their corresponding descriptive statistical measures along with generating functions are also derived. This is the function. Let x of omega be a random variable representing number of times state I occurs, a sequence of length 1. Then x of omega 1 will take two values, either 0 or 1. 0 means nothing happened, 1 means 1 times it's happened. So therefore, the probability mass function for taking probability that x1 omega 1 will be x, this will be when x equal to 1 it is pi 1, when x equal to 0 it is 1 minus pi 1, and it will be 0 otherwise. So by this time you have a probability mass function of a discrete probability distribution where the random variable is taking two values only, simply binary 0 and 1. So where pi is the probability of happening state I. So here we have derived different statistical characteristics based on the previous probability distribution. This is the probability distribution deals with increased state I it is. So for that, these are all the math formulae, derived mathematical formulae for finding, for example, kth order origin moment. This is the value. For all k takes 1, 2, 3, 4, so on, as you wish. Average number of increases, mean if you want, mean number of increment states obtained by 1. Variance is the formula. Third central moment is this formula. Fourth central moment is arrived this way. Beta 1, which is useful for coefficient of skewness. Beta 1 and gamma 1 deals with measures of skewness. And beta 2 and gamma 2 deals with measures of kurtosis and measures of excess. The coefficient of variation is also calculated. This formula is derived based on the previous probability distribution. Similarly, moment generating function, probability generating function, characteristic function also we have obtained. So this is all. In the previous slide, we have distributions, probability mass function. In the current slide, these are all the statistical characteristics or measures which are derived in math formula. Now, second one is, this is also probability distribution function for decrement state. Here, random variable denoted with y. Earlier, random variable denoted with x. That deals with the increment state probability distribution. Now, this deals with decrement state probability distribution. This is the PMF, where you have the probability mass function taking the real number values 0 and 1 only. Now, the different statistical characteristics derived, mathematical or explicit mathematical relations are, these are the things. Okay. That is kth order moments, mean, variance, third, fourth, central moments, beta 1, beta 2, gamma 1, gamma 2, MGF, PGF, characteristic function, everything was derived. This deals with one-day sequence, decreased state, probability distributions related statistical characteristics. Now, coming to the another one, 2-day sequence. For example, the happenings, I am reading up to 2 days sequence. Then what happened? We have the options like I and D, D and I, T and T. That means a string of 4 possibilities will come, out of which if you want to formulate a probability distribution, when x equal to 0, it is for increased state probability distribution of state 2-state Markov chain in consecutive trading days. Sequences are derived in this section. Let x of omega random variable, but it deals with 2-day sequence. This is the probability mass function. For which we have pi and A also. A deals with transition probability matrix. Now, these are all the statistical characteristics we derived. Kth order raw moment, mean, variance. These are all the mean, variance, first 4 central moments. After getting that, mean, variance, beta 1, mu 3, mu 4. These are all derived. Coefficient of variation. Next, beta 1, beta 2 also derived, gamma 1, gamma 2 also derived. So, after that, we have also derived moment generating function and probability generating function, characteristic function. This will help you to know the behavior of the population through this formulated probability distribution. This probability distribution has 4 transition probability parameters, 2 initial probability parameters. That means there are 6 parameters that are involved in this probability distribution. Now, coming to the same logic for increased state, decreased state, the probability mass function is this one. Similarly, statistical characteristics derived in mathematical relations are these one. And these are the different other statistical characteristics, coefficient of skewness, coefficient of kurtosis. These things will help you the shape of frequency curve and the humpedness or peakedness of the frequency curve. Similarly, MGF, PGF characteristic functions are also will help us to know the behavior of the probability distribution of decreased states in 2-day length sequence. Similarly, we have extended the same for 3-day sequence. This is the probability distribution, and these are the statistical characteristics for increment state. And on the same lines, we have discussed the other things also. Now, coming to, these are all the theoretical derivations. As a model developer, I have considered a two-state Markov model and derived the probability mass function. From the derived probability mass function, I have derived the mathematical relations or explicit mathematical relations for different statistical characteristics. These are all the formulae. Now, these formulae, mathematical concepts may not be reached to the customer. Customer always bothered about the numerical things. So therefore, we have considered a data set from the website yahoofinance.com, and the data we considered the periods from August 1st, 2018 to October 29, 2021, and around 794 daily trading days on closing price. On closing price of Nifty banks we have collected. So this is the data source. So this data now we are going to apply to the developed models and explore all the calculations. What happened? See, these are all the, it is the specimen data we have considered. Closing price data it is. For example, it is the current, day 1 data, it is day 2 data. So day 1 minus day 2 can have this value, and day 3 minus day 2 you have this value, and so on. So this is the way you have to find difference. Wherever you have minus or 0, you name it as a D state. Wherever you have S sign in the difference, it is I, state I. After that, we have identified the transitions of DI. For example, DI, this is the transition. Then I and I, this is transition. ID, this is another transition. DI, this is the transition. Next one is II, in fact. Sixth observation is also I. So thus this transition is II. And so on. For all 794, these states will come to 793, and transitions runs comes to 792 only. Right. So the graph, what it shows that it is completely transient. We cannot identify what are the patterns that are maybe. See, for example, from here to here, there is some pattern we are observing. From here to here, there is one pattern. From here to here, there is another pattern. Overall, from here to here, increment trend will be there. But here, there is no such. So therefore, there is a lot of stochasticity in the model. After observing the graph, total data, this is the revealing. So what I did is, I have find the residuals, and the residuals it is showing, this is the phenomenon. Residuals are also called volatility in closing prices. This is the graph it is showing. After observing this one, we have constructed a transition probability matrix using MS Excel. This is the code we have considered. This code is simply for finding different values. And what happened? Earlier I made it that I and D, total studies, 793 observations are there. Out of which, increment state is observed in 419 times. Increment state is observed for 374 times. So, the probability, initial probability is pi 1 is 0.5283, pi 2 is 0.47. Now, transition probabilities, as I said, I and I 234 times came. I and D 185 times came. D followed by I 185. D followed by D 188. This is how this one we have the transition frequency table. Once transition frequency table is obtained, you can get, see, this is the frequencies it is observing after the classifications. How many II, how many ID, how many DI. What it means that previous day increment, current day is increment is II. Previous day is increment, current day is decrement, that is ID. Previous day is decrement, current day is increment, that is DI. Previous day is decrements, current day also decrement, that is DD. That way you have to observe this one. After making that, the transition probability matrix, how it can be calculated. It is something like this row frequency, each row frequency, for example, 234 plus 185, 419. So 234 by 419 is the first probability. 185 by 419 is the second probability. So that way, this is the transition probability matrix we obtain. This means A11, A12, A21, A22. In the previous case, we have phi 1, phi 2. So phi 1, phi 2, A11, A12, A21, A22. All 6 parameters we have explored from the given data. So the schematic diagram without notations, this is the empirical model. This is the two-state Markov chain model with the data given. What it means that this is the transition probability increase to increase. This is the transition probability decrease to decrease. Increment to decrement, this is the probability. Decrement to increment, this is the probability. That way you have to understand. Now, after making that, actually A of power 1, that means order 1, Kolmogov's transition probability matrix A power 1, it is this one. It is completely transient. To order to find the stationarity, what we did is we have multiplied that matrix up to 7 times, then only that onwards you will have the same pattern. What it means that? See, increment is 0.529. These column values are same. These column values are same. When you are getting these probabilities of this nature, you have achieved the stationarity. So therefore, you have to spell about the behavior in future. So what it means that market is stabled at 7th day. At 7th day, after 794 observations, from 5th day onward, 7th day, after 7th day only, you would observe the stationarity. So finally, what the interpretation it is says that there is a 53% of likelihood there will be increment. There is 47% of likelihood for decrement. So in the market behavior, it is showing that increment has more chance than the decrement. So this is the indicator you are exploring from the data using the two-state Markov chain model. Now, this phenomenon we are making that finding the values like closing prices, etc. State probabilities for forecasting the closing prices. These closing prices, main purpose of this section is to forecast the prices. So, like stationarity, transition probability matrix, initial probabilities also we have obtained. Finally, we have to multiply this initial probability into transition probability matrix. You will arrive to the stationary initial probability matrix. So, these are all. Phi 1 means first order, phi 2 means second order. You can go for accordingly. So, we have obtained the different ordered computation of state probabilities. Increment state is phenomena is like this. Decrement state phenomena is this one. This is how you can understand the behavior. Now, expected number of visits. What it means that it is coming to the remaining to same state. This is the meaning. So expected number formulae is obtained. This is the formulae mu jjn, limit n tends to infinity, expectation of n jjn. Using this formulae, expected number of visits is arrived. Okay, this is expected number. For example, increment to increment it takes 3.2 times. Increment to decrement it takes 2.7 times. That way, you have to calculate expected number of visits. It's something like a revisit concept. Okay. Next. Determination of expected return time also. Once mu jj is obtained, you can find one mu jj can be obtained by 1 by pi j. Pi j means initial probabilities we have already. So find this mu jj and so that expected return time also can be calculated. So results of the probability distributions after finding that 1 day sequence, these are the probabilities. For 2 day sequence, what happened? 1 increment 0.46, 2 increments it is 0.29, 0 increments it is 0.23. Out of which, if you study 2 days data, it is observed that getting increment on 1 day has maximum likelihood. If you observe 1 day data, getting increment has maximum likelihood, 1 increment. And similarly, if you go there here in other sequences, 3 day sequences, and 0.43, all 3 days increment has maximum likelihood. And 4 day sequence, if you observe, this is highest likelihood, means you will observe 2 days increment is highest likely. So short-term investors use to observe these indicators, and accordingly they will decide when to sell the share and when to purchase the share that can be done with these distributions. This way, you have to make use of the probability distributions for that. Next, if you go for the next item, is that probability distributions. These are all the findings we have already discussed, and all these findings which will be helpful for decision making. Mostly it is when to purchase and when to sell. So these are all the different findings already I have discussed. I no need of reading again. So coming to the glance reports, findings of the statistical measures of the distributions, you see central moments, skewness, kurtosis for single day sequence. Mean is this one, variance is this one, mu3 is this one, coefficient of skewness is this one, beta 2, gamma 1, gamma 2, coefficient of variation. These are all the different numerical values which are calculated from the formulae. That formula is derived from the previous slides I have already explained. That formula in turn obtained from the probability distribution. That probability distribution in turn obtained from the two-state Markov chain model. This is the data related to a single day related. Similarly, next item is for 2 days and 3 days sequences also it was given. These are the mean, variance, mu3, mu4, beta 1, beta 2, gamma 1, gamma 2. Basing on this, you can understand what is the behavior of the data so that decision making. So if you want to know what is the volatility state, CV for 3 day sequence 0.49, for 2 day sequence 0.68. Coming to the previous slide, CV I am speaking. CV 105. So the number of days is less. The CV is more. See, the more the number of days sequence, the CV is lessing. What it means that the market is stabilizing. If you are happening, the study is more number of observations. This is what you can have different indicators with help of mean, variance, beta 1, beta 2, gamma 1, gamma 2, CV, etc. Okay, summary of findings, what it says that this study has considered two-state Markov chain model to the closing prices of Nifty banks to the share prices of SBI to analysis and predict their future behavior of the closing share prices. Since it is not possible to get the exact prediction value in an absolute form, the MCM explained the movement of stock price behavior and probability measures only. The initial probability vector, the transition probability matrix represents the next day probability of state increment and decrement in two-state Markov chain. It is observed from the TPM in two-state MCM that when the current state of Nifty bank closing price is an increasing state, the share price will also be an increasing state in the next day with the maximum likelihood. It is the meaning. Okay. So it is what my findings, the final findings are this study demonstrates how MCM fits the time series data and can forecast the moment because of its randomness capabilities, in which every state in the TPM may be reached directly by every other state, leading to favorable results. The findings of the study will surely help the future investors, particularly short-term investors and shareholders, to make their decision about when to buy and when to sell the shares of any company by applying the proposed methodologies in order to make more profits, or what it means that returns on their investment, ROI. So these are the references I have considered, and that's it for today. Thank you very much, sir, for your.
Thank you. Thank you, Pati Rao, sir.
I'm happy if any feedback given to me. I will be happy.
If there are any questions from audience, please. Participants.
If not audience, Professor Gute may give the feedback.
Sir, really you have delivered very nice and informative lecture in today's conference. It is actually real life.
Actually, it's my students' work, sir.
Yes.
That is the thesis work. We have worked a lot. It's a nice output we came. We got very nice output. Yes.
It is a real life applications that
Yes.
Many people can use in stock market for purchasing or selling their shares. So on behalf of organizing committee, I thanks Professor Tirupati Rao for delivering very nice and informative lectures in today's session. I also thanks for giving me opportunity to chair this session. Thank you.
Thank you. Thank you, one and all, sir. Thank you.
Thank you, sir.
Yes.
My special
Yes.
thanks goes to Professor Tirupati Rao Padi sir for delivering a wonderful talk on hidden Markov models of financial marketing, and also our institute is grateful to Professor P.B. Gute sir for chairing the session. Thank you, sir.
Thank you. Thank you, sir.
Okay. Now we will start the second invited talk. The topic of the invited talk is non-parametric tests for two sample location problem based on ranked set sampling, and the speaker is Dr. Deepak Sakte sir. He is head Department of Statistics, Central University of Tamil Nadu, and chairperson is Dr. B.G. Kore. He is principal Adarsh College, Vita. So, Kore sir, it's over to you.
Good morning, everybody. First of all, I want to express thanks to organizing committee for giving me opportunity for chairing this session. Now presently we are going to listen the invited talk number 2 by Dr. Deepak Sakte. I introduce him in short. My friend Dr. Deepak Sakte is presently working as an associate professor in the Department of Statistics and Applied Mathematics, Central University of Tamil Nadu. His educational qualification is he completed MSc in 2009 from Shivaji University, Kolhapur. In 2014, he completed PhD degree in statistics under the able guidance of Dr. D.N. Kasi. His professional experiences are: he was worked as an assistant professor in 2009 to 2010 in the Department of Statistics, School of Mathematical Sciences, North Maharashtra University, Jalgaon. After that, during 2015 to 2016, he is a postdoctoral fellow in the Department of Biostatistics and Epidemiology, Augusta University, Augusta, USA. After that, from 2010 to 2019, he worked as an assistant professor in the Department of Statistics, Shivaji University, Kolhapur. And from 2019, he working as associate professor in the Department of Statistics and Applied Mathematics, Central University of Tamil Nadu. He held many more academic administrative responsibilities. He working as a head of the department from August 2021 to till date, the Department of Statistics and Applied Mathematics, Central University of Tamil Nadu. He worked as a coordinator of postgraduate diploma in Actuarial Sciences, Shivaji University, Kolhapur, during 2014 to 2015. He worked as a coordinator for MPhil PhD course in the Shivaji University, Kolhapur, during 2018 to 2019. He held the responsibility of Task Force Committee member, International Affairs Cell, Shivaji University, Kolhapur. He is presently working as a research guide, and under his able guidance, 2 students are registered for PhD and 1 for MPhil. 1 PhD student is submitted his thesis. He has published more than 18 research papers in the national and international journals. He completed 1 minor research project. He delivered invited talks in conferences, seminars, workshops, and faculty development programs more than 43 times. He presented research papers in the conferences and seminars more than 14 times. He has organized workshops, seminar, conferences more than 12 times. He has membership of many academic bodies. He is a life member of IISA, life member of Indian Society of Probability and Statistics, ISPS. He is a life member of SUSTA and member of the Executive Committee of the SUSTA. Such a rich academic biodata of my friend Dr. Deepak Sakte. Now I request him to deliver his invited talk on the topic non-parametric tests for 2 sample location problem based on ranked set sampling. So please, Dr. Sakte.
Thank you very much, Principal Dr. B.G. Kore, for a very nice and long introduction. Some of you might have even gotten bored, maybe like 10-15 minutes speaking, just introducing the speech. Anyway, at the outset, let me thank organizers of this conference, particularly convener Mr. V.K. Gadge, and the principal of this college, Dr. S.M. Malani, Dr. Ganpatrao Deshmukh Mahavidyalaya, Sangola, for giving me an opportunity to express my views on one of my favorite topics of research. I shall keep myself very precise and stick to the topic. And as the title suggests, I'll be speaking on non-parametric tests for 2 sample location problem based on rank set exam. So let me share the screen first.
प्रॅक्टिकल घरी आहे का साहित्य प्रॅक्टिकल
Is my screen visible?
करतात मी तर काय सांगणार तुम्हाला तुमच्या ह्याच्यावर मी काय शाळा तुम्ही शिकणार आहे माझं ऍडमिशन द्यायचं फक्त काम आहे मी सगळे विषय शिकवणार आहे का
And am I audible clear?
Yes, sir.
तुमचं तुम्ही ठरवायचं मी काय सांगणार तुम्हाला
Yes, sir. Go ahead.
So, as I said, like I'll be speaking on non-parametric test for 2 sample location problem based on sampling. The roadmap for the presentation of next half an hour would be like I shall first introduce Rancid sampling through the definition, need, and of course through examples, and then we shall see a very famous problem in non-parametric statistical inference, two-sample location problem, and how it can be approached when the data is obtained through Rancid sampling rather than simple random sampling. I will see some existing tests available in the literature, and will try to propose a new test which may work for ranked sampling and be better than the existing tests. And we have performed some simulation study. I will share the results of simulation study and also illustrate the procedure through an application to a real data. Although, so to keep in line with the theme of the conference, that is statistics and its applications, I shall see that both the theory as well as applications are discussed in detail in my presentation. So this rank set sampling, some of you might not be aware of like why this rank set sampling is coming here. Usually people work with simple random sampling, which is more convenient and easy to handle as far as inference procedures are concerned. If we just have a look at whatever the inference we have studied throughout in our MSc and your undergraduate classes, nonetheless, we don't mention what sampling scheme is applied, but inherently we start with say latex 1x and be a random sample, and by that we mean we have a simple random sample. And our entire inference is based on simple random sample, which is being taught in undergraduate and postgraduate classes. So hardly people know like why, what is random sampling and why it is needed. So this slide essentially will tell us why random sampling is required and how this can be beneficial to do inference in certain situations. So as far as the simple random sampling is concerned, it assigns equal chance to every unit in the population to enter the sample. And in that way, we have a feeling like this may be a better representative, rather a good representative of the population. But when we look at the individual units in the SRS sample, we can only conclude that they are on an average, quote unquote, representative of the population. So whatever sample we get from SRS is not, the best representative of the population. And as a result, of course, we have seen many other sampling strategies like systematic sampling or stratified sampling or probability proportional to size sampling and so on. There are so many sampling procedures which are available in the literature, which perform better than simple random sampling as far as estimation of mean of a characteristic of interest is concerned. If we look at these procedures, which are alternative to SRS, they are all pre-stratification procedures. When I say pre, it means like some auxiliary information is used to stratify the population into subgroups, and then a simple random sampling is applied to collect data on sample units. But when we see at these procedures, they of course provide a better representative sample when the population is a structured population. But one thing is missed out, and that is like whatever auxiliary information was used to stratify the data or stratify the population, that information is left out, and only the sample obtained after stratification is used for further inference. So no use of extra information happens in these existing procedures from specific units. So then why not somebody think of a post-stratification procedure for performing sampling and then do inference, which may lead to a better understanding of the population. And as a result, like McIntyre in 1950, he thought of implementing a new sampling strategy as he was posed with some problems for implementation of SRS, simple random sampling. Ideally, this rancid sampling is used whenever we come across a situation wherein measuring the characteristic of interest is very costly or destructive, and we can measure alternatively a very highly correlated characteristic easily, even just by observation, not by any sophisticated. So if that is the situation, if we have an auxiliary information which is highly correlated with the characteristic of interest, and the characteristic of interest is measuring characteristic of interest is time consuming, expensive, and highly destructive. In such cases, one can go with rancid sampling. I'll talk about like how this is implemented, what exactly this rancid sampling is. As I said, like McIntyre, he in 1952 proposed the concept of rancid sampling in the context of obtaining reliable probability estimates based on sampling of pastures and crop plots. But of course, this procedure was not didn't attract much attention of the research because of the complicated nature of its implementation, and also the sample which we get is not completely so theoretical aspects were not touched by many people until Takahashi and Wakimoto in 1968 and Takahashi in 1970 developed basic statistical methodology for rancid sampling, particularly the proved properties for sample mean, and and they worked out the variance of the sample, and then established particularly that how it is better than simple random sample. And of course, later in 1988, Stokes and Sager did some work on inference about the population distribution function. This Stokes and Sager, they tried to prove the properties of empirical distribution function obtained using rancid sampling. And of course, we'll talk about this in detail at a later stage of my presentation. So how people used it? As I said, like wherever destruction is a problem, one can think of this rancid sampling. So as a result, this Samavi in 1999 applied rancid sampling for determination of normal ranges of bilirubin levels in blood for newborn babies. Ideally, in India, if you see, like whenever a newborn baby is there, most of the cases will get the newborn baby will get affected by jaundice, and people will start looking at the bilirubin levels to understand the severeness of the jaundice, and then accordingly the treatment can be prescribed. But measuring bilirubin levels of newborn babies requires blood sampling. And just imagine a newborn baby a day or two days old, and we are putting a needle in either arm or thigh to collect a blood sample. How much painful it would be for the newborn baby. With the thought itself, like our mind could shiver, and as a result, what could be an alternative to understand the bilirubin levels, and whether there is any strategy to apply so as to not to collect samples from each and every person, but rather from a few people. How it can be done? To establish such ranges, like blood sample must be taken from the sample babies and then tested in the laboratory. But puncturing every baby would be very troublesome. So how do we do it? So an information, like again, medical information is additionally available, and that is like the bilirubin levels of a small number of babies can mean that they can be ranked based on like observing whether their face, chest, lower parts of the body, and the terminal parts of the whole body are yellowish. And this is because the yellowish color goes from face to the terminal parts of the whole body, and the level of bilirubin goes. So they are like highly related, and therefore we can stratify or rather sort out the babies in such a way that we collect sample on the lowest level of bilirubin as well as the highest level, and as well as in between, by first looking at their yellowish color, like how much yellow it is, and depending on the strength of that yellowishness, it would be decided like whether to collect a sample from that baby or not. And this is how like things will be more clear in the further slides when we shall actually see how the strategy is. So, how exactly this rank sample is collected? So basically, we do a simple random sample. Of course, measurement is not done. That is very important. Only units are selected, but measurement is not done. So that is how we proceed. So first, an initial SRS of K units is selected from the population and rank ordered on the attribute of interest. This rank ordering is very, very important, and that actually carries the name rank set sample. So this rank ordering of the SRS sample on the attribute of interest is done through an auxiliary variable, and that auxiliary variable is actually measured, or you can say visually judged, and therefore the ordering happens through judgment and not by actual measurement. Even you don't need to measure the auxiliary variable, you can simply have a kind of a judgment, and based on that you can rank the observations or other units in the SRS sample in rank order fashion. And then the unit that is just to be smallest in this ranking is included as the first item in the axis, and the attribute of interest is formally measured for that unit. So like from a set of K units, only one unit will be selected for further analysis, and we can see like the smallest one will be selected, and then only for that unit the variable of interest or attribute of interest will be formally measured, and remaining units in that SRS will be discarded. That means no measurement on remaining units will be done. Then a fresh sample of another K units independent of earlier sample will be taken, and the second judgment order statistics will be found out. And the second judgment order statistics becomes a part of your rank sample. Process is repeated until you get K judgment statistics. So if we get all those K, so that K will constitute only, of course, judgment cannot be very vast. We can judge only like small, medium, high. So we cannot have a judgment to be very long. And if we do it in this way, our K, that set size will be very, K is called a set size. So that will be small only. It may be 3 or 4. And we cannot have more because our judgment will then suffer biasness if we increase K to a bigger number. So K is ideally 3 or 4, and that much sample only will get in a single run or single cycle. So, but the K being small, we cannot just rely on those many observations. That may be 3 or 4 in number, and we need more observations. Those can be obtained by performing m number of cycles to get a desired sample of size m. So this is how it is processed. I already explained about these slides. I will see on this slide particularly like how the cycle is implemented and what are these values. So X bracketed 1 is actually the first order statistic from SRS of size K. Then we go for the second SRS of size K, and we collect only second order statistic, and that is here. And we proceed in this manner till we get kth order statistic from the set size. Now this yields only k order statistics. Then we do the same process m number of times, and then we get this complete sample as a rank set sample. This I shall explain with the help of data, so that the idea will be crystallized. So this data is actually from Nussbaum and Sinha in 1997, who recommended using field RVP values. RVP values are nothing but ride vapor pressure for gasoline, and they are field RVP values are actually measured by a raw instrument, by I should say a crude instrument, which is not giving accurate values for RVP, but this RVP is a very important measure to understand the quality of gasoline. So these values are highly correlated with the more precise laboratory measurements, but working out these more precise laboratory measurements is highly expensive and takes a lot of time. So one cannot simply give a lot of values, samples, I should say, for laboratory measurement, but a few can be given. So based on field RVP values. So field RVP value provide a ranking mechanism for selection of a much smaller subgroup of gasoline samples to submit for follow-up laboratory analysis. So what they did, they considered a set size K of 3 and M is equals to 4 sizes. So which leads to N is equals to 12 gasoline samples finally. So the K into 4 will produce a sample of size 12. And then how many SRS units we shall need? For getting one cycle, we need K square number of units. So total number of SRS units which we shall require to get 12 gasoline samples would be 3 square multiplied by 4. That means 9 multiplied by 4, 36 units. So we shall start with the 36 size gasoline sample and shall reduce it to rank set sample of size 1. So to select this RSS using a set size of K equals to 3, these 12 gasoline samples to be sent to the laboratory for more precise measurements. The first thing we must do is to randomly divide these 36 gasoline samples into 12 sets, each of 12 sets of 3 each. So these are 12 sets, each of set size 3. And then based on the judgment, of course, now here this field RVP values provide a value. So no need to do any judgment. We can directly use the order statistics to decide which one is smallest, which one is second smallest, and so on. So these are the number of the observations from this data. You can see the sample number, field RVP values, again sample number, and field RVP values. So just imagine that all these are randomly, so what I said, like randomly grouped into 12 subgroups, each of size 3, and they are represented here. This is first group, second group, third group, then fourth, fifth, and so on. We have 12 groups. So this first group is considered as a first set of SRS of size K equals to 3, and then we look for the smallest of this. So for including into the ranked sample. So first smallest in this would be like 7.85. This is the value which will be entering your ranked sample. Then from the second one, we shall look for the second largest, and second largest is 8.60. And from the third one, we shall look for the highest, that is 9.25. This gives us a single set of order statistics, a single size. First order statistics from this first set, second order statistics from this, and then highest from this. Then we shall discard the remaining observations and then move on to the next set. Again, we shall do the same thing, first order statistics, then second order statistics, then third order statistics, and proceed this until we complete the 4 cycles. So all these bold faced numbers, they will be the part of rank set sample. Now, that was, like how exactly the rank set sampling is implemented, and now we shall talk about like why there is so much gap between the initial introduction of this rank set sampling in 1950s and then development of theoretical procedures in 1970s. So why 2 decades were gone and why nobody touched about or talked about these procedures? The reason is the complexity. As we have seen, like we need to discard some SRS units and then finally come up with a smaller thing. But this essentially leads to a much better representative of a population, and that will be clear from the theoretical properties. As we can see, Dell and Fletter in 1972 implemented this balance. Yeah, when I say balanced, whatever set size is there, those many order statistics if we work out, then the rank set sampling is to be balanced. If we work out less number of order statistics than set size, then it is called as unbalanced. We cannot go beyond that because set sizes will provide the largest number of order statistics. So that is only the terminology. When I say balanced, it means we get K number of order statistics from a single size. So in that case, it is called as balanced. if the number of order statistics is less than 3, it becomes unbalanced. So Redel letter proved that the estimate of mean from rank set sample has lesser variability or lesser variance than the corresponding estimate from simple random sample. The expression is there on the screen, and this was proved for a single cycle. And if it is true, you can say like if it is true for a single cycle, it is true for m number of cycles easily. So here we can see this mu star S is mean or rather expectation of S order statistic. As I said, like I'll talk more about estimation of empirical distribution, estimation of distribution function. Stokes and Sager were the first who gave an estimator of population distribution function through an empirical CDF for the RSS state, and the definition of empirical CDF is here. And they further showed that this FMKX given in this expression is an unbiased estimator of f. That is that coincides with the property of empirical distribution function from a simple random sample. But if you see at the variance of FMKX is smaller than variance of f at is CDF or empirical CDF based on f. So as far as distribution function estimation is also concerned, the rank set sample provides a better estimate for population distribution function. The story doesn't stop here, and then after these two properties proved for rank set sample, people started looking at this procedure as an attractive alternative, and now a lot of researchers are engaged in translating the procedures for simple random sampling to rank set sampling. That's the power of rank set sampling nowadays, and wherever needed, people are using rank set sampling for doing inference as contrast to simple random sampling. Coming to our celebrated two sample location problem, the problem is ideally highlighted through the hypothesis H0 F is equals to G, where F and G are two distribution functions, and alternatives F not equals to G. Of course, this delta comes into the definition of G, where G is nothing but if your F, here you can see particularly, this is your empirical, rather I could say, distribution function, FMF, and that is empirical in nature. GKY is another empirical distribution function for the second sample, and your G of t is related with F through this relation. So G of t is equals to F of t plus delta. So only there is a difference in the argument. The argument is replaced by t, is changed from t to t plus delta. Delta is in R. Delta essentially stands for location parameter, and the hypothesis of F equals to G at every t essentially reduces to testing delta equals to 0 versus delta not equals to 0. So we begin with two samples. One is denoted by X, other is denoted by Y, with different set sizes and so set size is M. In first sample, size is N. So sample size will be M into M. Similarly, for second sample, we have set size K and number of sizes Q. So sample size will be K into Q. So we have two samples with two different sample sizes. Of course, the structure is also different, and the problem is to test whether the two population distribution functions agree for location. A lot of approaches have been cited in the literature, but as far as rank sampling is concerned, only one test is available, and that is given by Bone and Wolf. But I just go ahead with some initial developments. Edmonds-Surger proposed a sign test based on RSS data and showed that RSS sign test is more efficient than SRS sign test, and this happened in 1995. Later on, Osterk in 1999 and Osterk and Wolf in 2000 suggested median transit sampling, and based on that, people proposed procedures, testing procedures for two sample location. Even in 2005 by Wang and Zhu, and in 2010 by Dong and Q, both they proposed weighted sign test under unbalanced RSS and proved the weighted version always improves the fitment efficiency for all distributors. And recently, of course I should not say recently, but a decade older, Wang et al. Discussed the sign test using RSS with unequal set sizes. So, if you look at the literature, as I said, like in 1992, Bone and Wolf came up with the RSS version of a celebrated test in a simple random sample, that is man-Whitney U test, and they translated the man-Whitney U statistic to Rancid sample, and that statistic happens to be one of the best statistics for these two samples till date, until we came up with an attractive alternative through the developments made by Lyman in 1963 and Fried and Darling later, who proposed tests, robust tests for two sample location problem for simple random samples. So we basically convert the tests from Fried and Darling, which highly depend on a Lemon estimator for location, which is robust in nature. It is given over here. You can see this del 2, del 1, and then del 3, and rather S1 and S2. These are estimates for the scales, and then the combination of this del 1, del 2, and S1, S2 in the ratio produces estimates for location in a robust way, which were used by Fried and Darling in 2011 to propose robust non-parametric tests for location. So we can see, like Fried Darling estimators, they are pouring number for different combinations of course. Just excuse me for the abuse of notation K here. This K is different than the set size which I produced, but simply this essentially stands for 1 and 2. So you just have del 1 formula, del and S1. That one combination will produce FD1. Then you put 2 here and S1, that will produce FD2, and so on. So basically, we have 4 test statistics, and fortunately, all these test statistics they reject the null hypothesis for large values of absolute CFD. So we translated the existing existing SRS versions to RSS versions and defined the robust version of location estimate based on Lemon and Fried and Darling, which finally produces this test statistic and the test criteria. We studied the location invariance of this RSS version of Fried and Darling test and found that the statistic is location invariant. And further, empirically, we established that the distribution of this test statistic is symmetric. The symmetry property is also satisfied, but of course we have not yet shown it analytically. Analytical proof is still under process. We further studied the performance of this RSS version of Fried and Darling statistic to simulation, and we fixed these parameters, rather I should say the specifications for simulation study. Set sizes were equal initially, and cycles were kept as 4 and 5, and 10,000 runs were implemented. Nominal level was 0.05, and these were the different distributions for which the simulation study was performed. Normal, exponential, Pearson type 3, and Cauchy, Pearson type 2, uniform, double exponential, and logistic. So this essentially gives us a wide variety of symmetric as well as skewed distributions. And we can see like yeah, so uh, that was for perfect BRSs. That means the number of perfect in the sense like the judgment statistic is available in perfect way, and therefore ordering is done by exactly the order statistics. So that is called as perfect balanced ranked sampling. And any imperfect is also available. In that case, how the performance is there, that also we counted for normal, exponential, and uniform distributions. So I'll show you the tables, how the performance will look like. So tables with perfect rank set, perfect balanced rank set sampling, and these are the powers of tests uh, under perfect balanced rank set sampling for different values of delta, that is a location shift for N1, N2, 12, M1, M2, 3, and R1, R2. As we can see, like for different distributions, this Fried and dialing, which are this T1, 2, T1, 1, and so on. Up to these are both statistics of Fried and dialing, and this one, this column represents bone wolf test. And we can see, like in certain distributions, like Cauchy and then Pearson, and also for uniform and even exponential,
Hello.
the proposed test statistic outperforms the bone wolf test. So that essentially gives us an attractive alternative. Even in logistics, you can see for small location shift also, it is highly detected, rather I should say strongly detected by the proposed test rather than existing bone wool test. There are so many tables for different combinations, and the story repeats in a similar fashion for all the combinations. I'm just running through the different tables. There are 24 in number. So we also have an imperfect RSS, and for that also the same results are produced. Correct. So I'll go back to my slides. Correct. After implementing the procedure, rather I should say after performing the simulation results, it is our prime duty to check whether the proposed procedure works really good for real data or not. And in that context, we applied the proposed procedure on real data given in Mooney 1990, and it involves effect of stress of blood pressure of males and females. So the data is essentially a univariate data consisting of heart rate and a weight of 36 females and 28 males. Hypothesis of interest is uh, to test whether there is significant location difference between weights of males and females. So we select sample of size 24 from male population with set size M1 6 and cycle size R1 4, and another sample of size 20 from female population with set size M2 5 and cycle size R2 4. And the exact p-values for test statistics, particularly Rancid version of Fried and Daily and the one word test, were often for implementing Fried and Daily test. We have to perform permutations and to compute exact p-values. 1 lakh permutations were performed to compute the exact p-values for the proposed RSS FD test. And of course, it is observed that the RSS FD test and Brunel test strongly reject the null hypothesis, and we conclude that there is a significant difference between the weights of males and females. And yeah, so finally I conclude that the proposed univariate tests are purely non-parametric in nature, and under univariate perfect RSS, FD is an attractive alternative. Of course, I should not simply say perfect for even imperfect RSS. FD is an attractive alternative to bone growth test for symmetric as well as skew distributions. These are my some selected references. Thank you. That ends my presentation. Thank you very much once again for giving me an opportunity to share my research results with this esteemed audience. Thank you. Any questions?
Very nicely delivered the talk on the topic non-parametric tests for two sample location problem based on ranked set sampling by Dr. Professor. Is there any question from the audience? Please. Anybody, any question? I think there is no question as usual. Okay. Thanks to the speaker, to Deepak Sakhte for delivering the nice lecture. Now I hand over the charge to the next session. And also thankful to the organizer, my friend Gadge sir and the principal Polani sir and all his team. Thank you very much, sir.
Thank you very much, sir.
Thank you, sir. We are very much grateful to Dr. Deepak Sakhte sir for your nice presentation. Also, we are grateful to Dr. B.G. Kore sir for chairing the session. Thank you, sir. Now we will move to the next invited talk, and the topic of the invited talk is content validation and scale development in biostatics, and the speaker is Dr. Anjali Upadhyay, biostatician and IQAC director, Anna Saheb Dange Ayurved College, Sangli, and the chairperson is Professor K.G. Potdar sir, head Department of Statistics, Azra Mahavidyalaya, Azra. So I request Professor K.G. Potdar sir to chair the session. Potdar sir, it's over to you.
Okay, thank you, sir.
Okay, sir.
Now next speaker is Dr. Anjali Upadhyay.
Yes, sir.
Okay. Currently working as a senior lecturer and head Department of Research in Honorable Sri Anna Saheb Dange Ayurvedic Medical College and Research Center, Asta, District Sangli. She also working as statistical consultant and mentor for NAC accreditation. She is also IQAC coordinator in her institute. She is chief editor of Indian Journal of Odyssey of Ayurveda, associate editor of Subhadra International Journal of Ayurveda. She published 7 books on various topics of statistics and published 33 research papers. Her area of interest is statistics, biostatistics, business statistics, quantitative techniques, research methodology, operational research, statistical inference, probability methods. Her educational qualification is MSc, MBA, PhD. She completed MSc in 1991 from Chuaj University, Kolhapur, MBA in 2010 from YCMOU, Nashik, PhD in 2015 from Tirath Maharashtra Vidyapith, Pune. She also completed PG Diploma in Total Quality Management and Advanced Diploma in Computer System Software. She is selected as National Member of Indian Society of Medical Statistics, Nodal Officer for Vidyanjali Higher Education Program, awarded as National Research Excellence Award by RSS Association, New Delhi. She completed 3 research projects. She participated as a resource person in more than 40 workshops and conferences. By this brief introduction, I request to Dr. Upadhyay Madam deliver her talk.
Thank you, sir. Thank you very much. I am very, hello, good morning all of you. Actually, I am very grateful to Dr. V.K. Gadge and our chief guest, Dr. S.S. Dastre, sir. I listened to Dr. V.B. Gute, sir. It is a very nice talk, actually. Those are explaining all the applications of statistics in various fields. Actually, I am very appreciated to Dr. S.M. Mulani, the principal of Dr. Ganpatrao Deshmukh Mahavidyalaya, Sangola. I am very grateful and thankful to them to give me this particular opportunity. Today, my topic is content validity and the skill development. I want to talk about this. I want to share the screen with you about the content validity.
आता काय आपण तर काय करणार असं ते पालक आहेत कोणतर विद्यार्थी नाही पालक आहेत आणि ते पालक प्रॉस्पेक्टस वगैरे घेऊन आले नाही नाही मग इकडे कॉन्फरन्स चालू आहे माझी ऑनलाईन मी कॉन्फरन्समध्ये कुठं बसलाय तुम्ही पोर्चमध्ये आहे ना हां
Is it visible to all?
खाली पोर्चमध्ये
Yes, ma'am.
Visible?
Yes, yes.
आता आहेत बसलीत मी आता फोन लावलाय तुमच्या समोर हां नाही असतात ते काय काय झालंय काहीतरी कामानिमित्त गेले असतील असतात ते सगळे असतात
So here we are starting the reliability, validity and content validation and the scale development. Okay. First of all, we will go that what exactly the, hello? Jagdish sir?
हॅलो मॅडम हॅलो
Jagdish sir? The slides are not rolling. Hello? Hello sir?
हॅलो मॅडम
Can you hear me?
यस मॅडम यस
स्लाइड्स मूव्ह होत नाहीयेत म्हणून मी तुम्हाला बोलवते.
मॅडम तुम्ही ते हे करा पहिल्यापासून स्लाइड ओपन करा
पहिल्यापासून स्टार्ट करू का? ओके ठीक. PDF वगैरे करायची गरज नाहीये ना सर?
काही गरज नाही स्लाइड
नाही ना ओके ठीक आहे.
हां मॅडम आता स्लाइड शो म्हणा खाली सगळ्यात शेवटी हां
ओके
ओके
ठीक.
नाव ओके हां कुठल्या वर्गाला BSc
So good morning all of you. I want to talk about the reliability, validity and content validation and scale development. Actually, this conference is about the applications of the statistics. I am working in a field of the biostatistics and last 11 years I am working in this particular field of medical sciences. I am dealing with the various medical fraternities as allopathy, homeopathy, Ayurveda, physiotherapy, nursing, and everywhere as being a research faculty of the Maharashtra Rajya University of Health Sciences, I am dealing with the various problems of the medical statistics. So this is the one of the new content, that is a content validation. Actually, the reliability, validity, and content validation, it is a part of statistics. But nowadays, there are some sciences which are the sciences which are called as a homeopathy, or maybe the Ayurveda, or the Unani, or a Siddha. These are the sciences that are not much recognized, and those are the individualized sciences, individualized health professionals. They have the qualitative all the data, but they don't have scales about it, and they need to develop a skills. So whenever they are setting a new skills, then those should be validated properly. And this my presentation is talking about that how we can going to validate that particular new skills in the health sciences, how we can do the skill development in the newly method. So this is one of my topic. So first of all, wherever we go, our goal of research. Our goal of research, it is to obtain the information Our goal of research to obtain the information for the relevant purpose of study. First of all, we have a proper finer criteria research question. According to the research question, we start our study. So, whenever the research question is set, we need to set the objectives of that particular study, and we set the hypothesis that what we are going to conclude about it. So, according to the research question, we collect the information with the maximal reliability and the validity. So first of all, we should understand what is the meaning of the reliability. Whether the research methods can reproduce the same results in the multiple times. Reliability is nothing but the repetition of the work. Repetition of the work with the reproducibility of the results. So whenever the reliable data is reliable, means it is a consistent, means it is a predictable. Wherever the reliability is there, then the data can be said to be related for the normality. So two types of reliability everybody known as that what is the external consistency procedures and internal consistency procedures. By these two procedures, we are going to decide the what is exactly the reliability in the data. So we will discuss about the external consistency procedures. Means where we compare the findings of the two independent processes of the data collection with each other. Okay. Wherever suppose we take a simple example of the anxiety test, then the same anxiety test can be given 2 times to the same person. Okay, but at the first time, a person is anxious to fill the test, but the second time he knows about all the results of that particular test, and it is applicable, and it is a practice of that. It is a memory effect that we cannot get the proper results or the success results from that. So this external consistency has a proper reliability of test and a retest. That is, we can repeat the test, but for the same different periods or the same period, or for the different administrations also, for the different areas also. So it have a memory effect and the practice effect also there in that particular consistency results. This may be happen with the parallel forms of reliability. The two equivalent forms of the test of the same attribute. Suppose we are taking the Maxwell's anxiety test and we are going through the James anxiety test. These are the two tests, but we can compare the results of these two tests parallelly with the same sample or maybe the different sample. Again, the same sample can be given the alternative forms of the test or the comparable forms of the reliability on the again different periods, on the different time spans, on the different areas. Therefore, we can get that the same results can be reproducible or not. That is why whenever we are dealing with this, that test, retest reliability and parallel forms of reliability. The second one is there is an internal consistency procedures. These are the three procedures to calculate the reliability of the data. First one is a split half reliability. Everybody know that we split the data into two halves and we are comparing that particular data. Second one, there is a Cooder-Richardson estimate of the reliability, which is a formula number 20, from which we can do the internal consistency. Third one, it is a Cronbach-Shalfa. Everybody know that Cronbach-Shalfa should be greater than 0.6. That is why we can understand there is a proper reliable solutions are there, or the data is a consistent or not. Internal consistency, external consistency can be due, and we can give the assurity that the data is a reliable. The second thing is that we are talking about the validity. What do you mean by validity? Exactly that whatever we got the results from the data, that result should satisfy our objectives as well as our hypothesis. So whenever we are measuring the exact degree that what we are claiming to measure, and that degree of measure is satisfying our validity. Everybody statistician knows that there are different types of validities. First one is a content validity. Content validity, normally we calculate the content validity with the Lache's method. Lache's method, that Lache has given the basic things, that three responses, that not necessary the response, Second one, useful but not essential. Third one, essential. In these three ways, we are calculating the essential content as a 1 and not essential contents as a 0. Therefore, with the lossless method, we do the content validity with the CVR is equal to NE minus N minus 2 divided by N minus 2. In this, whenever we want to do the content validity, whatever the data has been prepared or the questions has been prepared, the construct has been prepared, those are given to the different panel members. And these panel members are giving us the response. On the basis of that particular response, we are calculating the content validity. Second one, there is a criterion validity. What do you mean by criterion validity? Take a same example of the anxiety test. In this, the suppose XY test and YW test, those are the different tests, but those are given as an anxiety test. Therefore, different criteria, and similarly, the similar results, are they producing or not? This is the criterion validity. The same results are given to the one group or maybe the two groups or the other groups, and we are calculating the getting the similar results from that. Those are criterion or the concurrent validities. Again, in the constant validity, we are going to construct the dependent and independent variables under the one construct. Okay. So if we are getting the results correlation coefficients positive, then positive correlation coefficients or positive to our objectives, those are convergent validities, and those are not correlated. Those are also can be calculated, because in the health sciences, positive results and negative results both are all the applicable results. Therefore, those are the discriminant validity. In such a way, these are all the types of validity, and these all types of validity can be calculated with a proper factor analysis. So, how we measure this particular reliability and validity? Skill development and content validation are critical to meet the work in health, social and behavioral sciences, because majority of the data in the health, social and behavioral sciences are the qualitative type of data. Therefore, the data has to be converted into the proper numerical scales, but sometimes it is not possible. Therefore, there is a need of the skill development. Our goal was to concisely review the process of skill development and straightforward a matter as a possible, and both facilitate the development of new, valid, reliable skills, and to help the improve existing ones. Okay. Some scales are available, those are available in a market, those are paid scales, but whatever the scales has been developed, those may be in a different areas. Therefore, whatever the scales are reliable or applicable in our area, in our environment, in our climatic conditions, and for our feasibility, that should be created once. So, to do this, we have created a primer for best practices, that is a skill development. So, now what is the scope of this particular scale development procedure in the research, okay, or in a biostatistics? As the science advances, the novel questions are put forth and new scales become necessary. Scale development, it is a very obvious for these individualized sciences like homeopathy or Ayurveda, or Unani or Siddha. It is a necessary now that we develop a new skills. There are many steps for the skill development. There is a significant jargon between the different techniques, but the work can be done the costly and time consuming, but the complex statistical analysis is always required for this particular statistical analysis. So, furthermore, the health science and behavioral sciences degrees do not include the trainings on this particular skill development. Only the related statisticians knows that how to develop this particular scale. Therefore, there is a need of this particular training of training development. There are number of incomplete scales used in the measure of mental, physical, behavioral attributes. There is no fundamental our scientific inquiry. Therefore, there is always scope for the content validation in a biostatistics. Here we are discussing about one of the example, a simple example that I have taken here a simple example as a simple example of developing a constant and content validation of the emotional quotient. This is one of the example that we are going to discuss. Now, for this particular simple case study or this simple research, our objectives are to assess the scale development technique. that how you are going through the scale development techniques to determine the validity and reliability of the data in the scaled measurements. To developing the reliability and validity of the data, we are approving that these scales are very proper and they can be used in the generalized way. So we set a hypothesis that the scale of emotional quotient was not significantly reliable and valid, and alternative hypothesis as scale for the emotional quotient was significantly reliable and valid. So for this content validity, we are going through the phase 1. The phase 1, it is about the atom generation, that identification of the domain and the atom generation, that is selecting which atom to be tasked. That domain identification means for which purpose or for which research question we are going for the atom generation, or what type of questionnaire we have, how we are going to confirm the construct, which is called as a domain identification. Specify the purpose of the domain. Suppose we are talking about the emotional quotients, then which are the factors are related with the emotional quotient? Is the behavior is important? Is the talent is important? Is there conditioning is important? Or is there control is important? Is there individual is important? These are the domain factors, and we need to decide first of all that the domain identification specifies the purpose of the domain. Confirm there are no existing instruments. That means we take a review of literature and we are finding out that these domains are available or not. Okay, in the review of literature also we will find it. So the second one is we are going through the atom generation. Atom generation means we have to take a proper review of literature from the various literature sources like PubMed, Web of Science, Science Direct, or maybe the other UGC or Google Scholar. These are all the literature review databases like a cross reference, and we are going for the assessment of scales. There is a different research designs. As per the research designs, we need to generate the atoms for this particular in the phase of atom generation. So first of all, we are identifying the domain and the atom generation. Second one, in the phase 2, we are going through the content validity, that assessing these particular atoms adequately to measure the domain of experts. That means whatever the domain we have prepared, whatever the construct we have prepared, whatever the in a simple language, whatever the questionnaire we have prepared, that questionnaire has to be given to the expert judges. Then who are these particular expert judges? Those are maybe the professors in that particular field, or those are maybe the experts in that particular field, and those experts are giving the opinion about the data is a necessary, useful but essential, or the essential, or the relevant or not relevant. This is the judging from we are taken from the these particular judges, and we are applying the statistical procedures including the content validity ratio, content validity index, coefficient of alpha, Cronbach's alpha, and Delphi method by the expert judges. So this is the third step that we are evaluating the data by the experts. Now, after evaluating the experts, we are evaluation by the target population. Means what we are going to do. First of all, we will take an expert's opinion. With the expert's opinion, again we are finding the data with the Losch's method. Now, if the Losch's method proves that these scales are necessary, those are essential, and they can be judged with a particular population study, then we will take a pilot study. First of all, we will take a pilot study. And in the pilot study also the data is proving or the scale is proving particularly, then we will go for the phase number 2 as a scale development. Step number 3, the pre-testing questions, that is a pilot study, it is a very necessary, ensuring the questions and answers are meaningful. If we are getting the proper answers, meaningful answers from the respondents or maybe the patients, then we are fulfilling that particular data. And then we survey administration the sample size, gather the data from the right people, and after that we will do the factor analysis. So with the factor analysis, whatever the atoms or construct we have been prepared, the atom reduction process is over there. So step number 7, there is a test of dimensionality. That is a test of the latent construct has to be properly hypothesized which will do the test of Cronbach alpha, that is established responses are very consistent, internal consistency has been proved. Then the test of validity has been given. Now, and after that we will confirm that these particular scales are valid. For this, the valid content test, these are the some phases. In the summary, I have given this, that in a phase 1, which is a totally qualitative phase. Step 1, we are going through the data collection, in-depth interviews or the focus group discussions are there. In a step number 2, we are do the data analysis in thematic coding and themes for the skill development. In this phase, the review of literature phases comes under the phase 1. With the review of literature, we are doing for the atom generation phase. Phase number 2, it is a quantitative data that we are go for the atom generation with the help of the construct, with the help of review of literature, with the help of the domains that what we have been decided. So we'll go for the content validity test, the content validity by the proper factor analysis, and we'll go for the pilots testing. Again, we'll go for the data validation, exploratory research, and the atoms are finalized. And then whichever the scale we have been prepared, it is open, that question is open to give the results or take a responses and can be used in the process of data collection. Now we'll see. Now we have taken the particular example of emotional quotient. Is it there? So now here is our research question, that association between the final year medical students' emotional intelligence and the academic performance. Now this is our research question. Already the hypothesis and objectives we have been proved. So these are the 4 dimensions. We have taken the 4 dimensions. This is the 4 dimensions. That the first dimension is the control. The control indicates that how much control an individual has over the adverse situations. Okay, how much they can control. The control is not there. Is they stressed out? Is they reacting very stressfully, or is they reacting? Are they having any medical problems and all that? This is the control. The second one, it is a ownership. Ownership says that such as the exact reason for this particular adversity and willingness of the individual to take necessary measures. Okay, this is the ownership. The third dimension we have collected, it has indicates the content to which the trouble affects other areas of the individual life. Means whatever the anger is there, if the organizational behavior angle is there, and then is it spread to the family level. Okay, these are the some of the questions that they reach. And the last one dimension we have taken, it is endurance. Measures how to take along the problem and how it affects the last individual's life. Means whatever the adverse conditions are there, are they forgetting it? Are they keeping those memories in their life? Are they stressful about it? Are they having the health issues about it? It is the endurance. Therefore, these are the 4 dimensions that we have been prepared for the emotional quotient questionnaire. Now, this particular questionnaire we have given to the expert opinions. Now, the expert has to give our degree of relevance as number 1, the atom is not relevant to the dimension and to be measured. The 2, the atom is somewhat relevant to the dimension to be measured. The third one, the atom is quite relevant to the dimension to be measured. And the 4th one, the atom is highly relevant to the dimension to be measured of the constant. So in the last slide, we have seen the 4 dimensions, and on these 4 dimensions, we are taking the expert's opinion. Now, here is the dimension number 1, the control, and the questions, they have been prepared like this. You can read the questions. In the dimension control, we are saying that you are suffering the financial setback, or people respond unfavorably to the latest idea of the improvement of the organization, or your personal and work obligations are out of balance. You are exercising regularly, that you should know. Your computer crashed the 3rd time this week and you are lagging back of the work and overloaded it. These all situations having the stress, preparing the stress in that particular emotional quotient. Now, Dimension number 2 as a ownership. Now you can see in this slide that for each dimension the researcher prepared the 5 questions. 1, 2, 3, 4, 5. That means the construct is the one control. In this particular one construct, we have been prepared the 5 questions. Okay, this is the atoms. These are the atoms. We are generating the atoms under the dimension control or under the construct control. So one is the control and the atom generation is as the 5 questions. So the dimension number 2 is the ownership, and we have prepared the 5 questions for this. That you are overlooked the promotion. Someone you respect always purposely ignore your attempts of the discussion. In this way, we have prepared and this particular question is given to the expert or the judges for the degree of relevance. The judges has to fill only the tick mark in the degree of relevance. Either they feel that this question is necessary. Second one, this question is necessary, useful, but not essential. And the third one, it is essential questions that has to be put in the questionnaire. In this way, they can going to give the remark. This is the dimension number 3, which is the reach. 1, 2, 3, 4, 5. Again, the 5 questions are there. That reach, you are criticized for the brick project, high priority projects and important meetings that you are get cancelled. You hit a red light on your way, that you are getting late for the appointments. You never seem to be having the enough money. This again the reach. And the dimension number 4 as a endurance. You accidentally delete the important emails and you forgot to best friend's birthday. All the stress factors given you to have the effects on the family problems also. You are unable to take a much needed vacation or the holiday, or expensive searching, you cannot find your important documents. These are the endurance, that whatever the stress is there or a control, endurance, reach, and is directly affects to the long term effects are there with having this particular emotional quotient. Now you can see there here the expert has given the opinion for these all questions. As expert number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have preparing the 10 experts. But how many number of questions has to be taken as expertship? It is depends upon the researcher. That you may take a 5 experts or maybe the 10 up to the 15 experts or maybe the 40 experts you can take. Okay, but the Losch's method says that you can take maximum 40 experts to calculate, to take your opinions. So the next, here is the Losch's method. The Losch's says that there is a content validity index calculated by the Losch's method, that is a CVR is equal to NE minus N by 2 divided by N by 2. What do you mean by that? What is a NE? NE is a number of panel members indicating that the term is essential. Now in the previous slide, you are saying that the 4 things are there, 1, 2, 3, 4. Wherever is 3 is there, wherever 4 is there, only that one given as a 1, and wherever is the 1 and 2 is there, it is given as a 0. Therefore, here we are calculating the number of panel members indicating the term essential. That session has to be prepared, and we are calculating that NE minus N is equal to number of panel members. Number of panel members are there, and those are with this particular formula, CVR is equal to NE minus N minus 2 upon N minus 2. We are calculating the content validity. Now you can see here, by Losch's method, by the Losch's table, we are seeing the number of panelists are there and minimum value of the reliability. Suppose 5 members are there, then we have to just check it for the 0.99 value. But we have the 10 panel members. So for the 10 panel members, I need to find out that my CVR should be greater than 0.62. This is greater than 62. Therefore, the CVR, our CVR should be greater than 0.62. So you can see over here, suppose we have taken the 25 members, 25 experts. Then 25 experts says that the same thing, that they are saying the essential things, then we need to only the CVR value as a 0.37. Means number of panel members increases, then the CVR validity index should goes on decreasing. So in this example, we have taken this particular 10 panel members. For these 10 panel members, we are checking the value 0.62. Now see here. This is a particular calculation table by the Loshes method. So the atom numbers that whatever the questions we are preparing, the questions are called it as the atoms. So Q1, Q2, Q3, Q4, Q5. These are the questions. Any that we have been calculated, that any means number of experts says that it is essential. Now the n by 2, it is a 10 by 2, it is a 5. Now CVR calculated, it is a 0.80. 0.80, it is a greater than 0.62. Therefore, this question is a significant. Again, question number 2. Again, NE is 10, n by 2 is 5. Again, CVR is equal to 1. Therefore, it is a significant. Okay. But you can see this particular question number 9. Question number 9, the NE is equal to 7, n by 2 is equal to 5, and CVR is equal to 0.40, which is a less than 0.62. Therefore, this particular question has to be eliminated from the constraint. You can add the new question to the contents or new question to the constraint, but again, suppose you are adding that particular question, then again you have to go for the content validity index. Therefore, this particular question has to be eliminated or ignored, and we can see that how it is ignored by the factor analysis. So in this way, we are calculating the content validity index. Hello? Hello?
हाँ मॅडम
थोडंसं स्टक झालं, परत शेअर करायला लागेल का सर?
हाँ परत तुम्ही रिस्टार्ट करा, स्क्रोल होत नाहीत का स्लाइड्स?
Okay, I'm going to stop the sharing. I'll share the screen again because maybe the network problem may be there. Okay, we are here. So after this, that we have been prepared the content validity, then we are going through the average variance extracted and convergent. So we'll do the factor analysis. The two types of factor analysis we'll do, the exploratory factor analysis and confirmatory factor analysis. These two factor analysis we are do with the SPSS, then we will go further. So we have to again calculate the average variance extracted and what exactly the convergent and discriminant validity. So this is a convergent validity that we calculated the AVE and convergent validity CR. So this is a formula that factor loading, after the factor loading, we are finding that F1, this is particular F1, atom number V7, V6 and V5. How we can do this? These are doing with the SPSS with the factor analysis. Okay. Again, for the F2 factor, construct F1 is there, construct F2 is there, construct F3 is there. Therefore, again the atoms has been given V7, V6, V5. Now you can find out that whenever we are preparing the questions for the expert opinion, the sequence of that particular questions has been diversified or it is changed. It is changed because the factor loading says you that which questions has to be inserted in under the which construct. In this way, we can find the factor loading F1 has V7 question, V6 question and V5 questions. So we calculated the AVE, that is the average variance extracted, and the convergent validity also. So convergent validity, it is already 2.32, 1.74, 5.99 and this is a particular average is there. Therefore, this is going to the good scales that we have been preparing. Now, we are going through the discriminant validity. Again, these factors giving the AVE values are over here and the square roots are over here. So, for this, we are calculating these particular square roots in the CR. That is F1 0.86, again 0.57, 0.84 and this is a table about the discriminant validity. Now, for after that, we are going through the Cronbach-Alpha. Now, in the reliability factor analysis, we calculate the Cronbach-Alpha with a KMO Bartlett test. It is a Cronbach-Alpha 0.819. Now you can see that Cronbach-Alpha based on 0.820. Number of atoms are 10. So it is higher than 0.6. Therefore, data is reliable again. So for the confirmatory analysis, we go for the Amos SPSS, and whatever the factors we have been prepared, has been given to the Amos SPSS, and we are calculating the variances of it. A particular mean and variances can be overloaded here with the confirmatory analysis of Amos SPSS. Now, again we go for the chi-square test. That chi-square test value you can see over here, the chi-square value, it is 85.227. Okay, and the sample nodes are 55 and degrees of freedom with 32. Therefore, chi-square is also reliable. The model fits. Now, whenever we go for the model fitting summary, then C-mean, NPR values are, see the NPR values, C-mean values, that is the IMR values, those are again valid values. GFI values, those are again values. These are the values we are having with a Amos SPSS. So this is a particular table of the model fit of the Amos SPSS. That is a model chi-square. We have already calculated the chi-square values, which should be greater than 0.05. Therefore, the overall fit is there, and p-value is greater than 0.05, means our model is chi-square is valid. Again, the goodness of fit, GFI, again GFI it is a greater than 0.95, or average GFI it is a 0.90. Again we are having it is a 0.80, therefore again it is a valid. Now it is a TLI, normed fit index or a Tucker-Lewis index. Again NFI it is equal to greater than 0. This is the data given by the Amos SPSS as a model data. Therefore we are comparing these results with our results, and we are saying that either our scale is a valid or not. So RMSEA, root mean square of error of examination, it is less than 0.08. CFI greater than 0.90. SRMR less than 0.80. Therefore, these are model fits that we are comparing our results of the models with these particular results. These results are compared to this particular model results. Now we have a model fit with the Amos SPSS, and which says that CFI always varies with a 0 to 1. CFI value closest to 1 indicates that the good cutoff of the acceptable fit for the CMI greater than 0.90. But we have the value of CFI, it is a 0.80 in our scale development. So indicating 90% of the covariation of the data reproducible for your model. Okay. Second one, IFI. This should be again 0.90. 0.90, again it is a acceptable fit. Again TLI, again this is a TLI. Again RMASEA, these are all saying that this is a 0. These are all the standard values, and we are going to compare our standard values with that particular fit. So in the conclusion, whatever the emotional index, the case study we has been discussed, it is that says that it is a self-administered questionnaire which was used to gather the data from the researcher, and this questionnaire is divided into the 4 dimensions. The reliability of the scale was established by reporting the internal consistency and stability of the reliability with a Cronbach-Alpha 0.83. And in the previous slide of the CVI, we all see that those are all significant values. So the content validity was established by computing the atom level and the scale level content validity index. And CVI is equal to 1. So the panel of 10 members, and it is greater than 0.90. Therefore, it was acceptable. So making the scale development, we are putting this particular questionnaire as a very approachable and transparent, and we can facilitate for the any number of respondents or the patients to calculate the emotional quotients for the health, social and behavioral outcomes. This is a conclusion of our this particular case study. So in the conclusion, I want to say that well-designed scales are the foundation of much of our understanding of the range of phenomena, but ensuring that we accurately quantify that pervert the measure is not a simple matter. So scale development, it is a more approachable and transparent. So we hope to facilitate advancement of our understanding in the range of health, social and behavioral outcomes as a qualitative data. So this is from me. These are some references these are references for the SPSS, MOS SPSS and whatever the content validity. These are some references that I have. These are my books these books are written for the medical statistics. That the first one is a constructivism of medical statistics. These are the books. Those are approved by as a test books by the Maharashtra University of Health Sciences. And this is a book of statistical inference. Those are volume number 1, 2, 3, which is the syllabus of BSc Part 3 Science. And this is from by my side. So I always say to the all health professionals that take a help of always a proper statisticians, so they can help you to give the proper applicability of the data. That is why they can publish their papers and the research things in the proper websites and the proper database indices. So this is from me. This is my content. This is my side. So if you have any questions, you may ask me.
Any queries from participants? Any questions?
कोणाला काही क्वेश्चन्स असतील तर विचारा, काही प्रॉब्लेम नाहीये.
मॅडम नाहीत वाटतं, कुणाचे क्वेश्चन नाहीत, दिसत नाहीत.
Omre sir, it is not possible to summarize the data of content validity in a particular 40 minute or 50 minute, but I tried to be best. Is there any questions?
Okay, there is no questions. On behalf of organizers, I am thankful to Dr. Anjali Upadhyay for nice talk. I also thank to organizers for giving me this opportunity. Finally, I thanks to all participants. Okay,
thank you, sir. On behalf of our institute, we are very much grateful to Dr. Anjali Upadhyay madam. Madam has presented a nice work related to biostatics. Even 40 to 45 minutes are also more than sufficient. Madam, you have presented nice work, so thank you. Also, we are very much grateful to Professor K.G. Poddar sir for chairing the session. Thank you. Now the invited talks are over. The technical sessions will be started at 2 p.m. So all the participants are requested to join their respective Google Meet links at 2 p.m. So thank you. Thank you very much.
Thank you, sir.
Thank you. All the participants are requested to join their respective Google Meet link at 2 p.m. दुसरं काय सांगायचं आहे तुम्ही? चल ठीक, लिफ्ट करो, ये सर बंद करो.